Hi guys, I'm Mykola Mirshnachenko and welcome to my channel. This video is a recording of a call I had in my KMP for Android Developers School. If you want to join the school, I will leave a link in the description below. Since this was a recording of a call, it's not going to be as smooth as other videos, but I tried my best in editing only the interesting parts of the call, so I hope you enjoy it. And if you enjoyed this video, please put a like because it really helps me grow this channel. Thank you. This is actually a project that I use in my course for the KMP for Android Developers course, but I decided to use it to showcase this platform-specific dependency injection that I wanted to show. I'm just gonna go over quickly to explain how does Compose Multiplatform work so that Mohad, right? Mohad?
Yes.
Yeah,
So
so that
we are starting from basics like what is KMP and CMP, right?
uh-huh.
Okay,
Uh-huh.
okay.
Yeah,
Thank
yeah,
you, Mike.
Mohan. Yeah, by the way, welcome. I see Iqbal has joined us, right? Iqbal.
Yeah, it's right, Mikola.
Yeah, hello. Nice
Hello.
to meet you, and nice to see you here. Yeah, so I'm just gonna explain for Mohan here quickly how this Compose multi-platform work. So the way it's different from an Android project, this project it targets iOS also. So we have our shared code in common main, a code that is shared between iOS and Android. And then we have Android specific code in Android main and iOS specific code in iOS main. So that's like high level sort of overview of how this works. So whatever goes in common main, it must be applicable both to Android and iOS. So we can't put, for example, something that's very Android specific. So any Android API related Android API, not Kotlin API, cannot go in here. So for example, we cannot put, I don't know, like anything that works with contexts. It's simply not gonna resolve here. So it has to go into Android main. And then we have to work with that, and I'll show how that works later. Same thing for iOS. Anything that is specific only to iOS. For example, we have the HTTP client here with the Darwin engine. So Darwin applies only to iOS. So for example, I won't even be able to resolve this in Android main if we try this. So I have this HTTP client here. And if I try to change this one to Darwin, it's simply not going to work. It's not going to resolve. So as you can see, and it's not showing us anything, that we can import it because this dependency simply doesn't exist here. So that's like high level overview of how Compose multi-platform is structured. We have the dependencies also for our Compose app, which is these three basically projects for common main, iOS main, and Android main. And we have the separation here for Android main, iOS main dependencies, and common main dependencies. So is this so far understandable?
Yes. So if Android specific dependency is there, so
Mhm.
then we have to define that in Android main. But if it is common for both Android and iOS, then we have to define in common main. So
Yeah.
like this, we can get resolved that classes we need, right?
Yeah,
Okay.
everything that's in common main is already designed in such way that can be applied to iOS and Android. So all of these libraries, they work on multiple platforms, everything that's in common main. But this, for example, like the OKHTTP engine only works on Android. So it goes under Android main dependencies. And same thing for Darwin. It only works on iOS. And so this dependency goes under iOS main dependencies. Yeah, so that's basically how it works. So this project already has Koin. So I will show how it works here. And first I'll show you the project in general, what it is and what it looks like and what we'll be doing. Okay, it's right here. So yeah, this is a news app. We have the news articles here. This is fetched from news data IO. Oh, news data IO. Yeah. So this is the API that we're calling. And we also have the language API key here and the category. So the category is not yet implemented. So if whatever I click here, yeah, it's changing, but it's not yet being persisted to key value pairs. So for example, if we do this and kill this app, we would expect the education to stick. But if we kill it, we see that education here is not showing up. So what we want in our application is for this to stick whenever we kill the application. And we do that with key value storage, like shared preferences. So I will show you the app a little bit more in detail right now so that you guys understand how the code works. This app is not following any specific architecture, like clean architecture or whatever. It's just more like for demonstration purposes. So first I'll show you how Koin is structured. I have the Koin right here. Koin is actually very straightforward. I like it because it's not as complex. All you have to do when you want to define dependencies is, for example, we have an HTTP client here. So I have the HTTP client for Android and iOS. So for example, we have the iOS HTTP client here with the Darwin engine. So this builds an HTTP client and we can then bind this. So for example, we have this function right here, which is in our common main. We are configuring it here to work with our API. This is not really important right now. What is important is that we are creating platform HTTP client here with OK HTTP for Android and Darwin for iOS. So if we go here, you see that we have this expect function with an HTTP client, and you see that we have a definition in iOS main. And then if we go back, we also have a definition in our Android main. This is the most important part. This is where we create platform-specific dependencies. This is actually how we create them. So this is our platform-specific dependency here. And this one is already defined. So in a Koin, the module is simply where we have our dependencies. It's where we create them and where we provide them, and it's like a container for our dependencies. So here I am building our HTTP client with the platform specific engine. And then I bind this. I'm binding this to a class here, which is probably not that good, but I should be binding it to an interface so that I can then inject that interface where needed. I'll show that when we work with another dependency. So this is another dependency that we have. We have the view model here. The way it injects this is we have this kind of a scope view model off. The off thing, it essentially means that we are not providing the dependencies ourselves with the get. So if we were just doing this kind of stuff, the view model, then we would need to do the get here for it to work. So this is just a shorthand declaration right here of this. If we weren't doing the view model off, we would have to do view model and we would need to do this get. And this is simply automatically gets us whatever dependencies we have here. So in our case is a news data repository. And to avoid manually getting it like this, I'm using this shorthand DSL view model off. And same thing here. We have like this is the same thing as this one as a single. So this is the way we bind it to a HTTP client kind of interface or class. And this is another way we can do the binding. By binding, I mean we are taking a implementation and we are binding it to an interface. So we have the interface right here, get news data, and we are binding this implementation right here to our news data repo interface. As you can see here in our article view model, we are injecting this interface and Koin will know then what concrete dependency we want injected. So these are the 1 and 3 are essentially the same thing, but this one here, we can do multiple types of bindings. So we can bind a different kind of dependency to our news data repo, but that is some advanced stuff. So we're not going to be covering this as of now. So as of now, this is the basics of Koin. It's really simple. We have dependencies here, and Koin simply provides them automatically to us when we do the injection. All of these dependencies can be used for both platforms. Well, this one's not, but we're using expect actual here. But in general, they are applicable to Android and iOS. So in our application here, we have the categories. So we have the environment, food, health, whatever. So these are all the categories that we send to this endpoint of ours, news data IO latest, and we provide this category, which is optional. But the problem here is we want these category when we select them. So we want them to actually stick once we kill the app. So right now, if we kill it, you can see that it's not selected, which is not really a good user experience. So the way we would fix this is by using shared preferences or DataStore. DataStore. Whoops. I have the tie here, but I don't need tie. So you guys are familiar with the DataStore? Has anyone? Yeah, DataStore.
Yes.
Yeah.
Uh,
So that. Uh-huh.
Actually, I didn't use it for. I didn't know that it is now available for KMP2. There's another one by JetBrains called multi-platform settings, which do actually the same thing.
Multi-platform settings?
Yeah, I'm
Yeah.
also using multi-platform settings because it's more simple, I think, for me. Yeah, by Raswolf.
Yeah.
Oh, that one.
Wolf, yeah.
Yeah,
Yes.
that one.
Oh, okay. I didn't know this one. That's cool. Yeah, that's great. Now I'll know this one as well. I will take a look at it. Anyway, yeah. So I didn't know about this one, so I will use for this demonstration the data store for KMP. And the reason why I'm using this is because we need to implement platform-specific dependencies here. So I will actually just implement it right here with you guys. So I'm not going to be putting this into libs coin just for shortness. But yeah, the thing is that here we are forced to provide a dependency for Android and a dependency for iOS. So these are different. So we have to create different modules and we have to create different dependencies that are then used here in common main. So let's do this step by step. Okay, yeah, so we have imported the data store. Now I will define these right here, one for Android and one for iOS. Because this is an Android specific dependency, it will go inside our Android main right here. And I will create a data directory here, and I'll simply paste this and just import this stuff. Okay, and then I will import the same do the same for iOS. And this one goes into iOS main. I'll also name this data package and I'll also paste it. There we go. So all of these are iOS dependencies. As you can see, NS documentary, NS domain disk. And finally, I will use this thing which goes into our common main. we will also put it under data. And yeah, so there we go. Yeah, so what we're doing here is the platform-specific dependencies use our generic code here, which is in common main, and this does some production of some factory stuff and then produces a file, I guess, where it's written. And so this is the code for iOS, and this one is for goes into our Android. So these are the Android code. What's going on here? Oh, did I import a different one? Oh yeah, Java util. Okay, so and this one also uses the code from our common main here. Okay, so we have these dependencies, but we can't yet do anything with them because we are not using them in any way. Yeah, so here we go. We have our, actually I'll rename this because I don't want to create conflicts. So I'll call this Android Data Store, and I'll rename this function to create Android Data Store. And same thing here. I will rename this to iOS Data Store. Okay. Okay, yes. We have the iOS Data Store, and I'll just call this create iOS Data Store. Okay, so now we have the Android platform-specific dependency here, and we have the iOS platform-specific dependency here. So how do we use this? So we could use this like do expect actual stuff, but that is not really optimal because it'll make things a little bit more clunky. And we will do this with Koin, which I think it does it much more cleaner. So if we go to our common main here, the shared code, we have our app module. The problem here is that we can't use platform-specific dependencies here because, for example, we have the create Android data store. So it will simply will not see this here, won't resolve. So we can't create this in any way in our shared code. So to do this, we will create platform-specific modules. We will create an package with DI here. And inside this package, I will declare Android's module. And here I will do Android module, and import this. So this is a function from the Koin DSL, which creates the module for us. And inside this now we can declare our platform specific or Android module in our case. So what we want is we want to create our, Android data store. So we want to use this function to create our Android data store. And if we go to Android module here, so we want this to be a singleton. So we'll use single. Inside we will declare create Android store function. Okay, so a couple of things here. We need a shared interface for our iOS and our Android dependencies. In our case, we already have this interface here. So this data store is an interface that's provided to us. But if we didn't have this interface, we could have created it ourselves. So we can simply use this interface that's also used in the iOS data store. And since it's shared, we can bind our platform-specific dependencies to this interface. So where's our Android app module? Oh, there we go. So we will bind it by specifying it here inside our single type. There we go. So what this says essentially is create our Android data store and bind it to this interface. which is shared between iOS and Android. And then when we use this in our shared code, we will then use this interface to inject our Android specific dependency. And I'll show that later. So we bound this Android specific dependency to our data store here, but we have a problem because our Android dependency requires a context. And how do we provide a context here? The Koin DSL is we can simply do Android contexts. And this is also a Koin extension function that will fetch us our Android contexts. So we can simply do the Android contexts without specifying anything else because we have our Koin application composable at the very start of our app. And if we have this started as the core kind of composable in at the start of our app, this will set up Koin for us for Android, for iOS, for desktop, whatever. Then we can simply use this Android context like this. But previously we had to do this kind of start Koin function, and then inside we would declare a bunch of stuff. But we have this really nice composable that does this for us. So make sure you have this one before you do any injection because it will crash if not. So yeah, so this will actually now create a Android data store, and it will bind it to the preferences. Okay, so we have our Android module, and now let's just copy this over to our iOS. Oh wait, we don't have an iOS module yet, but let's create it. So we will go to iOS and create our package here and name it DI. And inside we will we'll just copy and paste the code for now. Import the module. I just copy and paste this. Okay. Yeah, this of course doesn't exist. Yeah, so we'll name this iOS module. And inside, since we don't have, of course, the create Android data store function here, we will use create iOS data store function. And our iOS data store function doesn't need any context or anything, so we can simply delete this. So here's our Android module, and this is our iOS module, and I will rename this because we want to avoid confusion. Yeah, and this is our same thing, creating iOS data store and binding it to our shared interface of data store. Okay, so we have defined the modules. Now our last thing that we need to do to make this actually work is we have to provide these modules to our Koin configuration. We do it by providing our platform specific module right here. Along with the modules, we would put our Android module or whatever, but this is our shared code. So we don't have access to our Android or iOS module here. So the way we do this is we have well, this is the way I'm doing it, but I guess maybe there is a better way to do it, but we search for an entry point for our Android and iOS application. So we have, for example, this is the entry point for Android application, and we will pass to our app our Android module. Okay, and here we will do a platform specific module. So this will, when we launch either iOS or Android, this will actually provide either the Android module or the iOS module, depending what platform we're launching. So that we have defined that for Android. Now let's search for iOS entry points. And here we will provide iOS module. This is pretty much it in terms of providing the platform specific stuff. So we will now just test to make sure that this actually works on Android and iOS, that we are actually saving stuff. And to save some time, I am simply going to copy and paste some stuff in our view model. Okay. So inside here we're fetching articles at the very start, and the category right now is null because we don't have any saved category. So I will swap this for a bit of a different thing. So here in our article view model, now we have to provide our data store that we have just built for Android and iOS. And as you can see, it's already the Copilot is recommending me to do this kind of a data store preferences. And I will actually accept this because that's the correct way to do this, is to do it through an interface. And this will figure out at runtime, it will provide right here either the Android or the iOS data store. So if we go also to our app module here, you can see that we are not changing anything here. We don't need to change it because we are using this shorthand DSL. So we don't need to add another get or something like that. Koin will simply substitute everything for us. We don't need to change anything. The only thing that we need to do is we need to inject our view model. And this is really simple. In our feed screen, which is the main screen right here, we simply provide the view model by doing Koin view model function. And this will provide us the article view model injection with Koin. Yeah, and so this is the stuff that I pasted. So we're injecting our data store here, which is at runtime will be either this one for iOS or this one for Android. And Koin will figure it out itself, which one it needs depending on the platform we start. And here, this needs to be defined. So this is some key value pair that we're going to be using for our category storage. So yeah, what this does is it goes to the data store, fetches the data that we have, and then we go through our category entries and we search if we have anything stored inside our data store. We will look for that by iterating over all categories. And then if it finds it, it's returning a flow, but actually there's just going to be a single value here. So it's going to be returning our saved category if it exists. It can be null. And then if we do have that saved category, we assign it to our selected category flow right there, which is then used on the UI. And we also pass it to our fetch articles, which does the requests to our news data IO. And one last thing that I need to add for this to work is once the category is selected, we also need to save it. So this will update the UI, but here we are also running DataStore. We're opening it for writing. And here we are saving whatever we have in our selected category here into our data store. So it will save into this key value pair, whatever we have for category, and we'll also do the fetch because we want that changed. So this should actually work now. Let's check this on Android and iOS. So let's choose domestic, for example. We chose domestic. Let's kill the app. And then let's launch it again. Yay, we see that it saves the domestic category. Now let's see this for iOS. Okay, now this, as you can see, works because I don't have any problem with the internet connection here. So let's click on environment and it switches to the environment news. And now let's kill the app. Okay, yay, we have the environment selected. So yeah, this is how we can build and inject platform-specific dependencies on Android, and I mean just in general in Compose Multiplatform. All right, so this has been a walkthrough on injecting platform-specific dependencies in Compose Multiplatform. If you want to see the full 1 hour long unedited video of this call, you can join the KMP for Android Developers School, and I have it posted there. If you guys enjoyed this video, please put a like, and thank you guys for watching, and I'll see you in the next video.